NPI.
Hi, on NPI, brought to you by DigiKey and Adafruit. This week, it's CUI devices. Lady Ada, what is this week's new product introduction?
This week's INPI is one of my favorite things. It's a USB PD power brick from CUI. All right, so you go to the next image. So what it looks like, it's basically like your kind of standard desktop power brick. This is a 30-watt power supply. It's got a USB-C cable on it, and it's a multi-voltage USB PD power supply that you can change the power plug to be US or UK or EU. And what I like about this series is the SDI 30 CUT series is basically this allows you to have a very high quality, low quiescent current, very efficient power supply that you can use for your products. It matches a lot of safety standards. It's UL, it's FCC, it's CE, all the safety and compliance you want. And the best part is because it's USB Type C PD, power delivery, you can use this one power plug for a vast number of projects and products that you may sell. So if you see down here, this is the data sheet. So can you expand?
You want me to?
Yeah, because I can do text. Yeah. So you can see at the bottom there, it says the output voltages. For example, 5 volts, you can get 3 amps, 9 volts, 3 amps, 15 volts, 12 amps, and 20 volts, 1.5 amps. So basically, 30 watts maximum. To get the maximum voltage, of course, you have to go to 15 or 20 volts. You can't get that at 5 volts because USB-C doesn't really like to give you more than 3 amps, no matter what the voltage. But the power supply will automatically select the correct voltage based on the USB-C device that it's plugged into. And I think that this is handy because this is a nice upgrade to what we've been using for the last 20, 30, 50 years, which is 5.5 millimeter / 2.1 millimeter DC jacks. You have these, I'm sure you have tons of these types of power adapters at home. They look like this. They're called wall warts because they're a little bit warty. You plug them in and you get that 2.1 / 5.5 millimeter jack on the end. But the thing that's really annoying is every power adapter is slightly different. So like this one, for example, is 9 volt, 1 amp, but you have to look on the label. Some are going to be 5 volts, 2 amps. Some are going to be 20 volts, half an amp. I mean, they can be any voltage, almost any current limiting amount. And some are, AC only, some are DC output, some are positive tip, some are negative tip. There's one connector, but it's used for a variety of different voltages and current capabilities. So, one solution is, you can have one of these adjustable adapters where you can dial in voltages. This is I think a 3 to 12 volt adapter, and you can see it's got that standard 5.5, 2.1 millimeter end. Here's one from another company where you can select different voltages and different tips. Almost everybody has one of these, and then you immediately lose the tips, and you're really annoyed because it's the one you wanted. So basically everybody has a gigantic pile of power supplies for all of the things in your house, and you can never throw anything away because that's the one power supply you need, because you need some weird voltage, 3 volts at 5 amps for your battery charger or something. So, a couple years ago, maybe 10, 15 years ago, a lot of companies, especially companies making small gadgets and electronic devices were we can't take it anymore. First off, the DC jack is a huge connector. Second, you never know what you're going to get, and the risk is very high that people are going to plug in the wrong kind of adapter. So let's go with USB, because USB is 5 volts, 5 watts, 1 amp, maybe 2 amps, so you can get 10 watts if you don't mind having a thick cable. So here's a CUI devices power adapter. It's nice and svelte. It's got this oval shape, very nifty looking. You plug USB in, and then you can use this to charge. I mean, this is really popularized by mobile phones. Everybody has this mobile phone or, mobile music player or GPS or watch or whatever electronic device that you charge over USB or micro USB. So you can get these with, this is a version of the adapter that has the micro USB plug in it. You have a Raspberry Pi computer, you're well aware that this is how you power your Raspberry Pi, or basically, or Arduino, whatever. Very, very common, and this works wonderfully as long as what you're powering is 5 volts and no more than 10 watts. So stuff that's powered off of a lithium-ion battery is great because lithium-ion batteries are 3.7 volts, 4.2 volts. You can power them and charge them from 5. You're good to go. But the thing is that this doesn't solve the problem for larger devices in the house. And that's where people basically said, look, we cannot, if you have a tablet, 10 watts is actually not really enough to charge or run a tablet or a laptop. So the USB implementation forum came up with the idea of power delivery, which you're starting to see in a bunch of devices. Basically, you can get up to 100 or even 200 watts of power, different voltages, and it's one plug, but the client device, not the power supply, but the power sink, negotiates. It tells the supply how much power, how much current, how much voltage it needs, and then the power delivery device does its best. So you can see here, for example, it's like, USB 2 really was supposed to be 2.5 watts, but really people used it at 5 watts. And then USB Type C, you can get up to 5 volts, 3 amps, with 1.2. And then PD, which is very common now. Almost everything is USB PD. 100 watts is easy, and multiple different voltages, which is great if you have devices that have 8.4 volts battery packs, so you need 9 or 12 volts to charge them, or it's a laptop, or it's a monitor, something like really needs a huge backlight or a lot of power. It needs, or it's a pump or something. It needs up to 100 watts of power. You can get that over USB-C. One thing to note, this is from the CUI blog, by the way. Check out the blog. They have a great, in the text version of this, there's a great blog post about USB PD. You cannot, this is kind of obvious, but I didn't realize it. Depending on the wattage you need, you're going to have to go with a voltage that will provide up to that much current, because you're really best off not trying to draw more than 3 amps over a USB Type-C cable. There are fancy cables that can do 5 amps, but people don't always have the fancy cable. So really do 3 amps, which means that, as you reach 30 watts, you can't use 5 volts anymore. You have to use 15 or maybe the higher end of 9. So just be aware, right? If you can't get more than 3 amps, if you need 60 watts, you need 20 volts to do that. And if you get into the higher voltages, you need these thick cables for USB-C that can carry 5 amps. But that said, you can, and this power adapter doesn't do more than 30 watts anyways, but if you get one of those 100 watt power supplies. One thing I recommend, and I'm going to show the demo with, is we stock in DigiKey stocks this little USB power throwing star. It's really great because it'll tell you whether what voltage was negotiated over USB PD. It's great for testing because not every device has some, as you design your device and you have the USB PD sync, you want to make sure that it works properly based on what power supply is plugged into, because now, if you're going to be using a power supply like this, people might plug it into their computer that cannot provide 12 volts or 20 volts. It can only provide 5. Your device just has to let people know, hey, I'm not in charge mode. I'm, in low power mode because I'm not getting the full amount, or basically somehow communicate. But to debug it, I recommend one of these little adapters. I use them every day. And we also have an excellent guide that one of our staff creative engineer R&D people wrote up all about USB-C. This graphic is also by a graphic designer. Check it out. It's on the learning system, learn.adafruit.com. Just search for USB Type-C. And then let me show off on the overhead this demo. So, okay. Here is the CUI devices. So the thing to note with USB PD is what you want to look at is the output. So, again, with non-USB PD power supplies, is going to say 5 volt 3 amps or 9 volt 1 amp. With this, it actually shows multiple voltages. And compare this to earlier power supplies where you'd actually have you'd sometimes get weirdo connectors with 4 pins because you'd get 5 volts and 12 volts. This one provides only 1 voltage, but it can provide any of these. So you don't get 20 volts at 1.5 amps plus 5 volts at 3 amps. You have to choose one or the other. And the way you choose is, again, there's this USB-C cable on the end. So I'm going to do a little bit of I did a little bit of a hack because it's I wanted to plug in different things. So for example, let's say I plug in, and this is my USB throwing star. So this is into the adapter, and this is going to just visualize what the voltage is that it's getting. So this is plugging into a QT which requires only 5 volts. So you can see the voltage, the V plus here, is 5.05. So it negotiated 5 volts. That's great. And then what I wanted to do is I wanted to plug in from last week. I showed off these funky cables that can give you, that they have a PD sync chip inside of them that will request 20 volts from it. And so I have a little like USB jack to jack adapter. So that's why I got that. I just wanted a quick adapter to convert the two. So you can plug in this cable, and then I have to re-plug it in. And this time, you'll see down here on the voltage, it says 19.8, so it got 20 volts. So basically, this cable, or the device you plug in, this CUI adapter, has to negotiate and say, hey, I want more than 5 volts. Use a special chip for that. There's a lot of companies that make them. They're only like $1 or $2. But this way, no matter what gets plugged in, it can request the right voltage. And if it doesn't get it, it will know that it didn't get the right voltage. So I recommend, if you're going to get this power supply, integrate it, debug with this, and of course also get a proper USB PD sync chip to go along.
Available on DigiKey.
In stock. There's 2 versions. One version has a power cable that's a USA, 3-prong, and one does not. So if you're like, why is one $25 and one's $20? The $25 one has the USB cable, the power cable.
That's on NPI.
On NPI.